Hello, and welcome to the Soils and Engineering Laboratory of the Department of Geology and Environmental Science, James Madison University. I'm Professor Scott Eaton, and today we'll give a demonstration of the operation of the Tyler mechanical sieve shaker and corresponding sieve analysis for soils that are mostly granular with some or no fines. For most standard sieve analysis, the sieve numbers of 4, 10, 20, 40, 60, 140, and 200 are generally used. Collect a representative soil sample ranging from 100 to 500 grams. For this laboratory, we will use 100 grams of sample. If needed, gently break the soil sample into individual particles using a mortar and pestle, rubber-tipped. You want to minimize the shattering of individual grains with that pestle, only separating the existing grains into their individual particles. Record the exact starting weight of your sample. Prepare the stack of sieves such that the sieve with the largest opening, usually the number 4 sieve, is on the top, and the size of the aperture decreases with depth down to the 200 sieve at the base, with the catch pan of the fines at the very bottom as the foundation. Gently load the stack of sieves into the mechanical shaker. Gently. Pour your representative sample into the top of the sieve, making sure that all of your sample is out of your tear. Place the cover on the top of the open stack of sieves, making note of the cork stopper. That should be on the top side of the cover so it can be in contact with the shaker. Set the time interval of the shaker to 10 minutes and longer for larger volumes of sample. Close the doors to help with noise reduction. Stop the shaker after 10 minutes. Carefully remove the stack of sieves and carry them to your weighing station. Now it's time to transfer your sediment in your number 4 sieve to a large pie pan. This minimizes the chances of losing sediment in the transfer process by using equal sizes of area. Use utensils very gently if you need to pop loose individual grains of sand left behind. Now take your sample and transfer it to a pre-weighed tare, which we are now doing. And the difference between the two weights is the weight of your sample retained in the number 4 sieve. Be sure to carefully record your data as you go along, cross-checking that you made no mistakes. Once you're done with your sample, you can return it to the overall collection of sediment that you started with, so we can recycle this for future use. Do the same procedure with each of the sieves until you have completed the process. Use the instruments of the brushes and the frosting knives carefully so that you do not damage the surfaces of the sieves. If a sample goes outside the pie pan, you can carefully pick up the individual particles and retransfer them back into this proper place. If a considerable amount of soil is retained on your final sieve, that is the 200 sieve, it has to be washed due to silt and clay particles clinging to the fine sands. First, weigh your contents as you have done previously for this sieve. Next, gently wash the sieve and its contents, that is, pour your sample back into the sieve, underneath the faucet with a tray underneath so you can monitor the clarity of the water. When the water passing through is clear, stop the rinsing and transfer that sample into a pre-weighed tare. Place in the oven for 24 hours and reweigh. This weight is the value of your 200 sieve. And the difference between the two values of before and after the weights is the extra silt and clay that was clinging to your sand particles. Add this extra value to what you measured in the catch pan. Once you are done with your weighing, put the sieves back together and put it back into the shaker for the next run. And as always, leave your space better than you found it. This concludes the overview of the operation of the Tyler sieve shaker, and I hope you've enjoyed this presentation.